Hi guys, today we are going to be learning about perpendicular lines and their relationships. Hopefully this sub has passed the note sheet out to you. So all you're going to do is you're just going to watch the video, follow the lesson, and just copy this down onto the note sheet. When you are done with this, there is some review problems on an additional video on the calendar to give you some practice before your quiz tomorrow. Okay, so let's take a look at number one and number two. It says, what can you conclude from the given information? Well, for number one, it says angle FIS, so that's this angle here from F to I to S, so here to here to here, is congruent to angle SIH, so from here to here to here. So if those are congruent here and here, it basically says what other information would we know in this diagram? Well, if they are congruent and they form a straight line like so, that means they're a linear pair. So that means that angle FIS plus angle SIH, their measures has to equal 180. Well, since both of them are congruent, that means we can just take that 180 and divide it by 2. So both of these two angles are actually going to be right angles. So we could actually say that this guy here is 90 degrees and this guy here is 90 degrees. So both angles would be right angles. Now for number two, it says segment HK, it should say line. My little guys, my arrows disappeared. Hopefully you guys have it on your sheet. Remember this little upside down T here? That stands for perpendicular. So it's basically saying that line HK is perpendicular to line UI. Well, what does perpendicular mean? If these two lines here are perpendicular, then that means they intersect to form a 90-degree angle. Well, if this is a 90-degree angle, that means this is also 90 degrees, this is 90, and this is 90. So all four of those angles are going to be 90 degrees, which would then mean that all of those angles are actually going to be congruent to one another. All right, so let's talk about distance and how perpendicular lines relate to distance. Okay, so distance, when you measure it, you have to always measure the distance between a point and a line, or two lines, or one person to another person. You have to measure that using perpendicular lines. Okay, so if we look at example A, it says draw the distance in the diagrams below. So when it just has that generic word distance, but it doesn't actually say the distance of SO or the distance of SX, what we want to do is we actually want to drop a line that's going to be perpendicular. So drop your segment from point S to your line that's going to be perpendicular to line OX. The reason why we do that is because when we are looking for distance, we always want the shortest path possible. Okay, so if we were to measure from S to O, that would obviously be longer than from point S straight down to that line. Same thing if we were to measure from S to X, like so, that would also be longer than the distance from point S straight down to line OX. Now for B, we have two parallel lines. So again, if we want to measure the distance, we want the shortest path from one line to the next. We're not just going to sit there and draw and measure random segments like this. What we want to do is we want to make sure that we have a segment that is going to meet both of those parallel lines at a 90-degree angle. And that would give you the shortest path. Okay? So hopefully that made sense. Feel free, you guys, to pause the video at any time so that you can catch up. Um, and forgive all of these extra little squiggles that are appearing in places. I don't know why that is happening. All right, so moving on. So let's talk then about using these perpendicular relationships. Okay, so for 3 and for 4, what you're going to do is you want to find the value of x in both of those diagrams and explain how you know the value of x based off of what's given to you in the information here. So looking at number 3, what would be the value of x? What do you guys think? Price? What do you think? Do you have a question? No? Okay. So if we have a 90-degree angle here, that means that these lines are perpendicular. So this would also be a 90-degree angle. So x is going to equal 90. Okay? Again, if this is 90 degrees, these are perpendicular. Since we have a linear pair here, they both have to add up to 180. If this is 90, this would be 180 minus 90, which means it's also 90 degrees. That's the long explanation for that. Now, for number 4, if we look, we have this 47-degree angle and x right here, okay? But then we have this right angle box in here. So that means that if we take that 47-degree angle, we add it to x, that's going to equal 90 degrees. Okay? So we subtract 47, and that's going to give us x equals 43. And that's it. All right, moving on. For number 5 and 6 on the back side, this can start to get a little tricky because you have multiple sets of lines that look like they could be parallel, that look like they could be perpendicular. Okay, so when you're trying to determine if any lines are parallel, this is when you want to look for those special angle relationships where you're looking at alternate interior angles being congruent, corresponding angles being congruent. You're looking for one of those 5 sets that we've been talking about this week. So sometimes the best way to do this is to actually just focus on 2 lines that look to be parallel and then pick a transversal. So let's take a look at line A and line G because they do look parallel. And now let's use, I don't know where that line just went. It disappeared, you guys. So let's use S as our possible transversal. So if you look at the intersection of S and A and then of S and G, you do not have any angle relationships happening here because you have actually no angles marked as being 90 degrees here, so you cannot relate anything back to this one. So that means that S is not going to be our transversal that would create any parallel lines. So let me erase this here. And now let's look at line A, line G, and then let's use N as our possible transversal. So again, if you look at this intersection, there's no angles that are marked as 90 degrees. If you look here, there's one angle, but you can't relate it back to anything at this intersection. So there's no way to determine if A and G are in fact going to be parallel to one another. Now let's take a look at S and N because they appear to be parallel as well. So here is line A, which could be one possible transversal. So again, look at the intersection of those lines. You see here again, there's no angles that are marked as 90 degrees, so you cannot relate any of these back to this one. And then finally, let's check to see if S and N are going to be parallel. Oops. With G as the transversal. So again, look at those intersections. There's no angles in here that are marked as 90 degrees. So you cannot relate this guy back to this guy at all. Now people tend to get confused with this type of question because they think, well, if one angle is 90 degrees, doesn't that make all other angles 90 degrees? And what you have to try to do here is you can't transversal hop. So what I mean by that is you cannot relate what's happening here to what's happening here. Because this intersection comes from lines A and S, this intersection comes from N and G. So that actually, those two intersections require 4 lines, whereas when we were talking about those special angle pairs, it was always 3 lines that were actually intersecting. So let me erase this. So kind of a counter example of this diagram is just to show you that all of these angles don't necessarily have to be 90 degrees. As if we have, line S, and then we have line A here. This could be a 90-degree angle still, okay, like in the diagram. But what I could do is I could actually rotate line N and line G. So here's N, here is line G right here. And I still have a 90-degree angle in that same spot, but I've taken this piece here and I've rotated it because we don't know what the angle measures are here and here. So remember, you can't assume from a diagram that even though it looks like it's 90 degrees, that it actually is going to be 90 degrees. You have to see that right angle box in there. Okay, so now let's move on to number 6, our last problem. So now we have 5 lines that are all intersecting. So again, you just want to start by picking 2 lines that look like they're going to be parallel. So let's take a look at M and S. Okay, now if we use line U as our possible transversal, there's no no angles marked at either one of these intersections. So that tells us nothing about lines M and S. All right, now if we use R as our transversal, we have an angle marked here, but we have no angle marked here. So we can't relate anything back to each other to prove that M and S would be parallel. And then finally, if we look at line M and line S, but we use D as our transversal, now if we look at those intersections, we do have 2 angles that actually are marked as being 90 degrees. So we have this guy here and we have this one here. They're both 90. Now, if this is our transversal, line D, and M and N are the 2 lines that are transversal hits, what kind of angle pair do these 90-degree angles form? Well, they're in the interior space of our lines, and they're on the same side of the transversal, so they're both on the right-hand side. So that would make these angles in here consecutive interior. Well, what do we know consecutive interior angles have to add up to if our lines are going to be parallel? They have to add up to 180. Well, do 2 90-degree angles add up to 180? And the answer is yes. So we could say, if we clean this up here, we could say that M is parallel to S, okay, because consecutive interior angles are supplementary. But again, we would have to use line D as our transversal for that. Now let's take a look and see if we can figure out if any other lines are going to be parallel in here. Okay, so as you guys can see, maybe you're already noticing this, we have this right angle here and this right angle here. Okay, so it looks like D and R are going to be parallel. And since if we look at line S as our possible transversal, we do in fact have two 90-degree angles that stem from line S. And they are both, if we look at their intersections here and here, they're both located in the top right and top right. So what type of angle pair would they be? Well, since they're in the same position, these guys would actually be corresponding angles, right? So these are corresponding. Now, if corresponding angles are congruent, then we can say that lines are parallel. Well, if we have two angles that are both 90 degrees, that means that yes, they are in fact congruent. So that tells us then that line D and line R are going to be parallel to each other because corresponding angles are congruent. But again, we have to use a specific line, and this time it's line S, as our transversal. If we tried to use, let me change colors here. If we tried to use line M as our transversal, again, there's no angles that we can relate back to each other because there's no right angles marked off of line R here. So hopefully this made some sense and you guys can kind of try to figure out what lines would be parallel. Sometimes it's helpful to actually cover up part of your diagram and just focus on two lines and then one transversal at a time. So when you guys have finished this, go ahead and stop the video and then you're going to go to the Canvas calendar and there is a second video for you to watch where you guys are going to do some practice problems in your notes. All right, I'll see you guys in the next video.